Assalamualaikum warahmatullahi wabarakatuh. Good morning to every one of you, also to the assessor. Today I'm going to present final year project 2, which is a research-based study of the application of convolution neural network on diagnosing diabetic retinopathy. In this study, it is a research study that we use convolution neural network, which is kind of neural network, and it is implemented on an image as the input data to make a classification of the diagnosis. So when we have a new data or new input from any patient, we feed into this neural network and it will give you what kind of the disease that the patient is having. So convolution neural network is a deep learning neural network architecture solution for image or video classification and segmentation problem. And this study is to detect the stages of diabetic retinopathy condition, where for this study we only want to classify 3 conditions, which is the healthy, the moderate condition, and the proliferative, which is the bad or the most risk patient, the most risk condition of the patient having diabetic, and the condition can be take a look into the eyes. And we do this through a deep learning framework or library called TensorFlow, which is a library software library that has been released and open source from Google to be used as anyone want to get to know deep learning and machine learning stuff. And it is aimed to replace the traditional feature extraction method, which is commonly known in the machine learning society of feature extraction, where usually we have an input and then we take the feature extraction from the image and then we train the image. So this method, we have a lot of images, we train it first with a label and then we get the results. Instead of doing feature extraction in the beginning, we do the train first. From the training we get the feature extraction and then we get the results, the accuracy results. Why I plan to do deep learning? Because deep learning is no longer computational expensive, as we already know the hardware of the computer already evolved from low computation to high computation. So we use this computational to do the deep learning compute. Next, the project background. The background or the motivation of the study is to increase the number of this is to decrease the number of diabetic patients in developing countries. So when we diagnose faster, early with this new method, we can reduce the number of patients and we can detect early. Also this is blood diagnosis takes time for, and also this is to reduce the invasive method where we take the pinch of blood on the finger to do the test. So by taking diagnosis faster with the fundus image, we can reduce the time for a country that have a very large population, such as we can say Africa or Indonesia or even Malaysia as well, and we can prevent the permanent blindness. So diabetic retinopathy, the proliferative condition, can tend to give someone with this condition of permanent blindness. So the permanent blindness usually happen in someone that in the range of 25 to 60 years old, according to research by Jamie Rapusiono, the Associate Program Director, Family Medicine Residency. And diabetic retinopathy is also has been we can say that in worldwide we have about 60% of the population have the diabetic retinopathy. It's very big numbers. So we aim to make the treatment go faster so that we can take the number down. The problem statement is this method is actually aimed to replace the not so old-fashioned feature extraction method that has been done in machine learning. So we take the image, train, and get the result. It's very quick, like 3 or 4 steps of doing this. And as the increment number of diabetic patients in developing countries per year, we aim to reduce this. So this is the problem, where we have a very big numbers of patients per year in a year, such as Africa or even any other country in developing countries. So we aim to reduce this. So this is the problem that has been faced worldwide. And the other problem is the slow diagnosing method, which is we use the normally as we before now we use the finger pinch. We take the blood sample and we put into this like kind of a reader that give you the reading, right? So when we deal with a lot of people, we deal with a lot of community, it takes a long time. So it is a slow diagnosing method of when we're dealing with high number of patients. And the objective, yes, to reduce the time taken for diagnosing diabetic patient. Patient come, we take the image of his or her eyes, we put into this classifier on this deep learning model, we get the result quick, and then we can move to the next step, either to give the medicine or if it's healthy then it is okay. And to develop an early non-invasive method of diagnosing diabetic. So this is non-invasive because we have the image of the eye, put into the classifier, the classifier does classification for us, and then we get the result, either the patient is diabetic or non-diabetic. To create a suitable models with correct accuracy for diagnosing benchmark. Yes, we train a lot of data, create a benchmark, which one has the higher accuracy with the lower or the lowest and very performing model. So the scope of the study is to design a reliable image processing method for automatic detection of diabetic retinal abnormalities, and also to develop a method for automated detection of diabetic fundus photography with adoption of image quality. So this is automated detection because when we have the input of the patient, so the software can already tell if the patient is diabetic or non-diabetic. The limitation of the study is that we need a lot of images. A lot here means not like 100. We need thousands of, we can say like terabytes of petabytes of images to create a very high accuracy model that can be used to do the classification. And some of the images that I faced during the study is that I have a large input size of the data. It means like for every image I have like 4000 by 4000 of height and width, which is very high resolution of image, and that will make computational hunger or computational expensive according to hardware definition. And I also have different size of input. Some of the input has 4000 by 4000, some 3000 by 3000, some much more bigger that takes time to process. So the literature review is based on previous study done by this example of two team of researcher, diagnosing of diabetic retinopathy using machine learning classification algorithm by Karan Bhatia, Shika Arora, and Ravi Tomar. And the method is to they propose a logistic regression, neural networks, and support vector machine, or SVM for short, and they published the work in 2016, which is 4 years ago. And the second previous study is a dictionary learning based method for detection of diabetic retinopathy in color fundus images by Narjas Karami and Hussein Rabbani. This method they propose is the color distinguish of healthy and non-healthy, which the algorithm can differentiate the color of a healthy and color of non-healthy patient. Non-healthy means the patient have diabetic retinopathy. They also use the learning of dictionaries, and later they do the classification from the dictionary. The work published on 2017, which is 3 years ago. The next is the methodology, okay, or as I mentioned earlier, the method is convolutional network, which is a deep learning method. So the first is I gather a lot of images data from publicly available retina image database, which is mostly got from the Kaggle, which is a data scientist platform for machine learning and deep learning project. And I apply a deep learning approach, which is in this is CNN. In this work, I propose 3 CNN, which is the code, the design architecture that developed by me, and the transfer learning, which I take mobile net architecture and use the final layer of the mobile net to train my dataset. And the third one is the NASNet, Neural Architecture Search, which is an architecture that can develop a new model based on the data that we put in. And NASNet is actually a recurrent neural network that can create another network such as convolutional neural network out of the box and train the data with it. And we feed the data into the model for computation. So all of these three methods will go through computational. So the next is replacing machine learning. Yes, machine learning feature extraction. We want to make it quick for machine learning and apply new image scanning technology backed by deep learning. So how CNN works? So let me show you the feature extraction in deep learning. We have this pixel of images. This is example of 5 by 5 input data. We have for example an pixel of 1 1 1 0 0 0, and then we have the convolution layers where we have an filter of 3 by 3. We put on each pixel on these images and we multiply it with the filter, and we move with stride. We stride the move from left to the right, one by one, and we compute, and we got a new images where it is already been make it small for a new mesh. We called it feature extraction. This is feature map. This is here is the feature map. This example of CNN can be looked like this. We have the source pixel, which is the images, the input image, and then we have the convolution filter, and then we have the destination pixel where we create a new images, which is end up to be in our model here. And the result is in the form of tree, where this is the result of the training from scratch, where I build my architecture for myself and then try to train with all the input data that I have. So we have a total input of, in this case, is 11974. This is design the fourth layer. We have 4 layers of 64 neuron for each layer. We have 5 layers of 64, and we also have 4 layers of 64 neuron, and the last is 128. And all the training went for 4 epochs. Some are 8 epochs, and 4 epochs. The training automatically stop as we reach the very lowest loss and the high accuracy that we can get from the architecture that I wrote. The high accuracy that I can gain 35.81% of accuracy, with the validation almost as close as it can get. And the transfer learning result is the higher is the 85.94, with a training set of 4000 epoch of the split of training 70% and 50% for the validation and the test dataset. For a batch of 128, means that for every epoch we fed in 128 images per run. And this is the AutoML result from where we use the NASNet architecture. The higher accuracy that I can get from the training is the 82.70, which is the highest for the 1464 input. Then all this data have been divided into 390 for training, 48 and 48 for training, and for validation and test dataset. I think that's all for today. So if you have any question, you can ask later. Thank you for listening.